Hello everyone, welcome back to another lesson, or a continued lesson if you've been with us for a while, on sigma notation. So what I'm going to be doing in this next portion of the lesson is I'm going to be revising what sigma notation is, and then I'm going to go into an example illustrating it. Let's look at the board together. So guys, at this point, we're going to revise that I can actually use sigma for arithmetic series as well as use it for geometric series. But before I get into those examples, let's just remind ourselves of what sigma notation actually is. So sigma is an instruction to determine the sum of a sequence. The use of sigma in a series gives us the opportunity to add any consecutive terms in a sequence together and not only the first n terms. So guys, just a reminder of what's quite cool about sigma is the fact that I can actually add a certain portion of terms of the sequence together. I don't have to start at term 1 going to the last term. I could add terms together from term 3 to term 10, from term 20 to term 22. It doesn't actually matter. Sigma allows us to either do the whole sequence going from term 1 to the last term, or to do an addition of a portion of terms in the sequence. Let's go to the next slide. So just a reminder, everybody, that when we are using sigma to calculate the value of a series, please remember to always write down the first 3 terms of the sequence. So we know that sigma means that we are going to be doing a series, but we are going to write down the first 3 terms of the sequence. This is going to allow us to establish the value of A as well as D if it is an arithmetic series. And we will establish the value of R with the first 3 terms if it is a geometric series. Great. So we have another example for us here. We can see that it is sigma notation because I actually have my sigma sign. And I have been asked to sum the Tn, this is the Tn, which is 3 times 2 to the power of n minus 1 from the first term. We know it's the first term, as n is equal to 1 will indicate the first term. And we are going to add all the terms from the first term up to the 10th term. So this sum will have the first term up to the 10th term. But before I can actually think about substituting into any series formula, I need to determine the value of my first 3 terms. So what we're going to do to establish the value of the first 3 terms is we're going to substitute when n is equal to 1, when n is equal to 2, and when n is equal to 3. That's going to allow me to find term 1, term 2, as well as term 3. So when I substitute n is equal to 1, I'm going to have 3 times 2 to the power of 1 minus 1. That is just going to leave me with 3. So term 1 is equal to 3. Then what I'm going to do is have term 2, 3 times 2 to the power of 2 minus 1, which is going to leave me with 6. Then term 3 is 3 times 2 to the power of 3 minus 1, and that is going to give me an answer of 12. So because I actually have the first 3 terms of the sequence, I can start determining the values of what I will need for my series formula. So everyone, I hope that you're okay at this point. I've established the first 3 terms in this sequence. Something that we do have to triple check before we substitute into the series formula is I need to make sure I know what type of series it is. Because, as we know, the arithmetic series formula is different to the geometric series formula. We're going to look out to see if there is a common difference or if there is a common ratio. If there is a common difference, I know that it's an arithmetic series. If there is a common ratio, I know it is a geometric series. Great, let's go back to the board. So, coming from here, I can see that from 3 to 6, I've added 3, but I've also multiplied by 2. From 6 to 12, I've added 6, but I again multiplied by 2. So I'm sure everyone will agree that having plus 3 and plus 6, that's not a common difference. But I can see that from 3 to 6, I can multiply 3 by 2 to get to 6, and I can multiply 6 by 2 to get to 12. So this example actually has a common ratio of positive 2. So that means that it is a geometric series. The last thing that I need to do before I substitute into the geometric series formula is determine how many terms are in this sum. So just a reminder, I take the top number minus the bottom number, then I add 1. So I'm going to have the top number, which is 10. I'm going to subtract the bottom number, which is 1. Then I'm going to add 1. So that means that there are 10 terms in this sequence. Great, guys. Also, just before we go on, I'm sure you'll agree with me that A is in fact 3 as it is term 1. So I have my A, I have my R, and I have my N, so I can substitute into the geometric series formula. So we know that geometric series can be written as A, 1 minus R to the power of N, over 1 minus R. So the sum of the first 10 terms, I'm going to substitute in my A, which is 3. I'm going to have 1 minus 2 to the power of 10, substituting in my R and N, over 1 minus 2. Great, let's just pop this into my calculator. I've got 3 times 1 minus 2 to the power of 10, all over 1 minus 2, which is going to give me 3,069. So guys, the sum of the first 10 terms of this geometric series is 3,069. After the break, we'll go through some more examples. See you soon.